Hello everyone, welcome back to my channel. For today's session, we will see how to implement linear queue using linked list. So first, what is meant by linear queue? So linear queue is a linear data structure in which we are trying to add the element at one end, that is nothing but the rear end, and we are removing element from one end, which is called as front of your queue. So now we want to implement this linear queue with the help of linked list. So just to implement this linear queue using linked list, single linked list is sufficient. So here we are going to use a single linked list to implement a linear queue. So the node structure for your linear queue is nothing but we are going to consider a data as well as a next pointer. So depending on application, you can define your own structure for your node. After that, as we already discussed, we are performing insertion at the rear end and deletion from the front end. These two pointers we are going to initialize in case of your linear queue. So now we will check the operation on linear queue. So the first operation is nothing but in queue. That means inserting a data into a queue. So when you want to perform insertion, you are going to perform at the rear end. So rear end is nothing but the after the last node of single linked list, we are inserting a data. That means we are performing insertion at the end of single linked list for enqueue operation. As we already discussed in case of single linked list, same method here we are using. So first we will allocate the memory for the new node. We will read data for the new node as well as assign the data to the new node. After that, there are two possibilities. Your queue is empty or your linear queue is not empty. So first, how to check your queue is empty? So if your front is equal to null, you can say that your linked list is empty. And whatever the new node you are trying to insert into a queue, that become a first node of your queue. So for that reason, new node is assigned to the both front and rear of your queue. As well as we need to set it next to the null because currently our queue is having a single node. That is nothing but the new node, that is nothing but the rear, and that is nothing but the front. So that was a first case. Now we will check for the second case. Your queue is not empty. So definitely we are going to perform the insertion at the rear end in case of queue. That is nothing but we are performing insertion at the end of single linked list. So when you want to insert a data at the end of queue, we are going to insert after rear. When you are adding this new node into the existing queue, we are adding after the rear end. So we need to make a connection from rear to the new node. So we can make a statement rear next equal to new node. After that, adding this 40 into a queue, its next we need to set to the null because it is the last element of our queue. So for that reason, new node next equal to null, this statement is given. And after adding the new node at the rear end, this new node become new rear for our queue. So in that case, we will update a rear end with the help of new node. This is a simple way how to perform enqueue operation in case of your linear queue. Now we will check a second operation, that is nothing but dequeue. So when you want to perform dequeue operation in case of your linear queue, there are three possibilities. First possibility is your queue is empty. Second possibility, your queue is having a single node. And third possibility is queue is having more than one element. So now let us start with the first case. If you want to perform dequeue, that means you are going to delete element or we can say the node from your queue. So here we are deleting from front end of our queue. That means dequeue operation of linear queue is done with the help of deleting a front element or deleting the start node of a single linked list. So first case is nothing but queue is empty. So how to check your linear queue is empty? You can check with the help of front equal to null. So if your front equal to null, we can say that your linear queue is empty and it is not possible for us to perform a dequeue operation. Second case is nothing but your queue is having a single node. So first thing, how you are going to check your queue is having a single node? So you can check with the help of front equal to rear. If your front and rear both pointer pointing to the same address, we can say that your queue is having a single node. Or you can use a concept like front next equal to null. Then also we can say that your queue is having a single node. and you want to delete that single node from your queue. So for that, we will hold that front into a temporary variable. So after deleting the front, that means currently it is rear also, we need to set the front as well as rear value to the null, because after deleting single node, your queue become empty. If you want to print a data of deleted node, you can print it with the help of temp data. And whatever the memory is allocated for this front or for this node, we can free it with the help of free temp. So that's all about your second case. Now we will check for the third case. So third case is nothing but queue is having more than one element. So here I am considering a queue with three elements 10, 20 and 30. So I want to perform a dequeue operation. That means I am going to delete the first node, or we can say the front node of our queue. So for that reason I will hold a temporary variable with the front of a queue. After deleting this front, we need to update its next element as a new front. So for that, front is equal to front next, this statement is given. If you want to print a deleted data, you can print it with the help of temp data. And whatever the memory is allocated for this front can be free with the help of free temp. So this is about the third case of your dequeue operation. Now we will check how to display a queue. So when you want to go for display a linear queue with the help of linked list, there are two possibilities, that is nothing but queue is empty and queue is not empty. So if your front is set to the null, you can say that queue is empty and it is not possible for you to display any data. Now we will check for the second case, that is your queue is not empty, and in that case you want to perform a traverse operation. So here I am considering a three element of my queue, that is 10, 20 and 30. I want to display this 10, 20 and 30. 10 is the front of my queue and 30 is rear end of my queue. So for traversing, I will use a temporary variable. That temporary variable holds the value of front. After that, we will use while temp is not equal to null. Every time I am going to print a temp data, and I will traverse a queue with the help of temp is equal to temp next. So initially your temp is pointing to the temp. After that I will check while condition. So temp is not equal to null. So in that I will print a data 10 and I will update the temp to the temp next. So now my temp is pointing to the 20. So again I will check the temp value. So it is not equal to null. In that case 20 data is printed and I will update the temp with temp next. That is nothing but temp is currently pointing to 30. After that, again while loop will be executed, it will go for checking 30 is not equal to null. Condition satisfy, it will print the value as 30 and temp is updated with the temp next. So now your temp is pointing to the null. So when I go for the next iteration, at that moment it won't be executed and we will come out of the while loop. So the data 10, 20 and 30 is printed with the help of this while loop. Hope so it is clear to you how to implement linear queue using linked list. So here we are using a single linked list for the implementation of linear queue. If you like this video, don't forget to subscribe my channel. Thank you.